If you're interested in learning how to code folding polyhedral nets using Manim, stay tuned, I've got you covered. This is a second installment of a video series I'm trying out, thanks to the Talking Maths in Public organizers who have this beautiful website that they have here. Under their website, they are running what they are calling an animation generation collaboration. It's a community project to create and publish process videos of mathematical animations using a range of different techniques and processes. I create my videos in Manim, and so I thought I would try to follow their lists. Last month, I did show how to create the classic circle and sine curve animation using Manim, and you can check that out on my channel. This month, I'm trying to follow along and show an animation of a net of a polyhedron opening and closing. So I was going to start and show a net of a tetrahedron and show it fold up into a tetrahedron and then maybe unfold back to the net. And then I think I have a strategy to basically copy and paste that code, make a few minor tweaks, and I'll be able to show a cube starting flat as a net and then folding up into the cube and then unfolding again. Okay, as you can see, I have a basically blank Python file open here. I've imported the important library from Manim. Again, I'm using ManimGL. And these first two lines just get me started. I've created a class. Notice because I'm going to need a three-dimensional scene, I've input 3D scene here, and then I've had it construct itself. I'm going to start, as you can see by the name of the class, by trying to fold the tetrahedron. In order to do this, the first thing I want to do is I am going to need access to the camera's frame. So I'm going to rename it frame, and it's self.camera.frame. You don't have to do this, but it just makes things a little easier than typing self.camera.frame each time. And then to begin with, I'm going to set the Euler angles. That's the rotation that you view on the screen. And I'm going to have the theta angle equal 0 times degrees. So that's 0 radians or 0 degrees. And I'm going to have the phi angle equal 0 times degrees as well. So right now we're just going to be looking down on it as if it's a flat XY plane, exactly as we might expect. The next thing I'm going to need to do is that I'm going to need some sort of triangle class. And there is a triangle class that's built in, but I'm going to define my own because eventually I'm going to want to center it at the right place. So I'm going to call it a triangle. It's going to take in a color and it's going to take in an opacity level, which I'll just call op. Okay, so to draw this, I'll call it T. It's going to be a polygon, and I want it to be a regular or equilateral triangle, regular three-gon. And for me, I'm going to have it go from -1, 0, 0 to 1, 0, 0, and then that means it has a base length of 2. So the middle x-coordinate is 0, and then the equilateral triangle has a height of square root of 3 when it has a base of length 2. I'm going to add a couple features here. So I'm going to change the fill to a color, whatever I feed it, and I'm going to change the opacity to the op level. And then I am going to return T. So down here, I'm going to generate one of these just to see what it looks like. A triangle. Tri equals a triangle. I'm going to take in a color, so blue, and I'll change the opacity level right now to 0.6 and see what that does. And just to see that it shows up, I'll try self.add try, go here, and I will load this up. And there we go. As you can see, it forms a nice equilateral triangle. Now, one thing that I'm interested in actually is I'd like this triangle to be centered at the origin. There's a couple ways to do that, but the easiest way actually is to take this polygon and to shift it down. I think math.tangent of pi over 6. And so that's just so that we shift the center. And we'll run this again and see. It did not actually shift it. Oh, it shifted it up. So I have to put a negative sign there. Try one more time. And now you can see it is actually perfectly centered around the origin. And there's a reason that I want to do this. And let's talk about it now. So one way that I'm going to go about doing this is I'm going to draw 4 triangles. And then I'm going to have one of them rotate around the bottom. And then I'm going to have it rotate around the center of the triangle. So I'm going to draw all 4 triangles on top of each other, rotate 3 of them around this line, and then I'm going to rotate 2 of them around the center of the triangle. So how am I going to do that? Well, first I'm going to call I'm going to group them all together. I'll call this the tries. I'm going to make it a V group, so that's a group of objects. And then what I want to do is I want to have a bunch of these triangles. So a triangle blue for I in range 4. So this should give me 4 of those. And then I've listed that this asterisk lists out everything in the list. So this is a list of 4 triangles using list comprehension in Python. And then this star should list them all out. And then the tries. And because I haven't done anything, it's just going to draw all 4 triangles. So you can't see them, but they have all been drawn there. So a couple things I want to do is to sort of track the colors of the triangles. I'm going to create a colors list. The first color will be blue, the next color will be red, the next color will be yellow, and then let's try green. And then in here, I should be able to change the colors to I. I might want to mess with this opacity level, so op level, and then I'll change op level here to 0.6. So let's see if this runs okay. There we go. And now you can see this color change to yellow, and that's because I'm drawing these all on top of one another with a certain opacity level, so you can't see any of them. But I have in fact created a group of 4 triangles. You just can't see them yet. So what I need to do is I need to rotate those triangles, and here's what I'm going to do that. So the 0th triangle is going to stay in the center where it is. So I'm going to run a for loop for I in the range 1 to 4. So that's going to stop at 3. I'm going to take the tries. I'm going to take the ith triangle. I am going to rotate it around pi and about point equals 0, 0, 0. So I'm rotating it about the center point. Then I am going to take the tries, take that ith triangle. I'm going to shift it. Okay, so this is sort of weird. I'm going to shift it. And what I essentially want is I want the 2 vertices of the triangles to match up. So I want to shift this triangle that I'm looking at, the ith triangle. I want to get its vertices, and I want to shift that to the origin, which is what I've done there. And then I want to take that corner and I want to shift it to the 0th triangle, which is my centrally located triangle. And I want to shift that to the first vertex of the 0th triangle. And so if I do this right now, what we should see is good. So the blue triangle is my 0th triangle, and it stayed at the middle, but all the other 3 triangles have rotated and then shifted up so that they glue perfectly onto this triangle. So the last thing that I need to do then is I need to take the ith triangle, I, and I need to rotate it 2 times pi times, okay, so I minus 1. This is because I'm starting at I equals 1. I don't want the first one to rotate. I want it to stay where it is, divided by 3. And I want to do this again about the point 0, 0, 0. So when I do this, what I did there is I drew all the triangles down here, but now I rotated them each an angle of 2 pi over 3, multiple of 2 pi over 3 around the center. So the red one stayed fixed because that was when I was 0, or I was 1, so that I rotated 0. When I was 1, I went to the 2, I went to the yellow triangle and I rotated 1 copy of 2 pi over 3. And then when I was 3, I went to the green triangle and I rotated 4 pi over 3 and it ended up there. So now what I have is I have a nice triangular shape that I want. And what I essentially want to do is I want to rotate the green, the yellow, and the red triangles up so that they form the tetrahedron. And so this is the trick. I've set it up here so that hopefully this should work pretty well. I need to rotate in a 3D way. So in order to do this, I'm going to have to define my own 3D matrix. I'm going to call it rotation matrix. It's going to take a direction and it's going to take an angle. So I am going to define 3 of these so that I can do a variety of different rotations. So if the direction is in the YZ coordinate, I'm going to create a matrix, which is, so a matrix is going to be like a list of 3 lists. Because I'm rotating in the YZ, I don't want to move the X at all. And then in the Y and Z direction, I need to put the rotation matrix, which is 0 in the X component, math.cosine of the angle that I'm rotating, negative math.sine of the angle that I'm rotating. Oops, ang is what I'm calling it. And then for this last list, I do the same thing, 0, except the second entry is math.sine of ang. And the last one is math.cosine of ang. Okay. And so if I've done everything right, I hope that's right. Now I'm just going to take this and I'm going to do it 2 more times. So what are the other 2? So the second one is L if. So on the other hand, if I don't put in yz, but I do put in xz, then I want to rotate around the xz coordinate. So that means I want to keep y fixed. And that's going to be my second vector. So I'm going to grab that. Okay, so my second vector fixes y. And then my first vector is going to be this exact same thing, except with the y at 0. So that's going to be an xz. And then I need to do the same thing down here. I need my x and my z's to be changing, but not my y's. And finally, this last one will be anything else, which is going to be if I have technically so this was the yz direction, yz rotation, xz rotation. And so now I'm going to have what would be xy rotation. And to do that, I am going to fix the z coordinate. So I'll go down here and fix the z coordinate at 0, 0, 1. That means these other entries need 0, and I don't have 0 there, and I have 0 there, and I don't have 0 there. So I've built this rotation matrix, even though I didn't need to build all 3 directions. I just like to do that so that I have it if I want to do any kinds of rotations. And so the trick here then is that I'm going to need some rotation angle. So I'm going to call that A. It's going to be a value tracker object. And for right now, I'm going to start with A as 0. So I'm not going to do any rotation. And then what I'm going to do is right here after I rotated it, it turns out the first thing I want to do is I also want to rotate it then in that using that rotation matrix. And to do that, we can use the command apply matrix, and then we can apply a matrix. And so for me, it's rotation matrix. I have to choose a direction. I want to do in a YZ direction because we want to keep the X fixed. And then I had to give it an angle, and the angle is a.getValue. So with any luck, this did absolutely nothing except that I got an error. So I have to go see what I might have done. Looks like I've caused a problem up here. Oh, right. So I defined all these matrices and then I totally forgot. Maybe I should return the matrix so that this command actually does get a matrix and returns it. So let's see if I can do that. And sure enough, there we go. And as I told you, nothing happened. And that's because I basically told it to rotate 0 radians in the YZ direction. But what if I were to change that to say 1 and try it? Then you should see, it's hard to sort of see, but all of those, the green, the yellow, and the red, have technically all pointed up 1 radian. And so right now I'm going to leave it at 0, but then basically my trick is going to be that now I'm going to redo all of this work that I just did and add the triangles, add an updater to the triangles that then continually updates based on the value tracker. So that's not so bad to do. So I have to define an updater. I'll call it try updater because for lack of a better language, it takes in an object, which I'll call mob, so mathematical object. And then essentially I'm just going to recopy this code. So I want to create these triangles again, and then I want to do the same thing with this code. Now, I don't want to name them the same thing because I don't want to mess with things, so I'll just call this temp tries. This is my temporary triangles that I create. And then I do the same thing to those temporary triangles. And the only difference is essentially nothing, but I need to change all of these things. And the try 0 doesn't really have to change because that triangle is always fixed, so I can leave that. So essentially, I just copied and pasted this, and then I just need to say that the object that I feed into it needs to become this temp tries object. So by adding the updater will continually look for a.getValue and will keep rotating as necessary. Okay, so now that I have done that, I need to add the updater. So the tries. I'm going to add the updater. And the updater is called try updater. And then basically I should be able to self.play. I should be able to take that value A and animate it and set it to a particular value like 1. And I'll run time kind of slow. So I'll run time kind of 3. And we can watch this play out. So it shows the thing. And then you notice all of those folded up. Now, it was hard to sort of see that. So the first thing then that maybe I should do is before I even do that, first of all, I think it's going to look nicer if I fade in the triangles. So I'll fade them in, and then I'll wait for a second so we can watch it. And now what I want is I actually want my frame to rotate. So here's where I can do that. I've called my frame, and I can animate it, and I can set the Euler angles. And I don't want to mess with the theta, but I do want to set the phi angle to 70 degrees. And we'll have that run a little slow, so we'll run in about 3 seconds there as well. And then we'll wait at the end. So let's see what this did. So if anything worked correctly, it should rotate me down so that that triangle is now looking sort of flat. And then you can actually see as I change those radians, they run. Now, something went wrong. They rotated opposite of what I wanted. That's not too bad. I should be able to change that to -1. And so now when I run it this time, it should do this and look like that. And now it should rotate in the opposite direction. Now you'll notice I didn't rotate the full angle. So the last thing I have to do is rotate that full angle. And I think to do that, the idea that I should be able to do is, so I think I want to rotate it pi minus 1.23. So let's see what that does. So I had to go look up the radian angle for the interior angle, and you can see, oh, it did it right, but it went the wrong way again. Of course, I should have done that. So negative. So I want to rotate it to this angle value here, and let's try one more time. And this time, with any luck, it rotates up, and sure enough, it creates that nice tetrahedron like I wanted. So basically I've done the fold up like I wanted to. I've kept the opacity level. The one thing that I might do to make this a little more fun looking is instead of just doing this kind of play, I could do something like self.play. I can do a lagged start. So here I can do a lag start. I'm going to take the frame and I'm going to animate it. What I want to do is I want to set the Euler angles. Now what I want to do is I do want to rotate the theta. So I'm animating theta going to 360 degrees. So that should rotate it around the central axis 360. And then, so that's my lag start. And then in my lag start, I should also now do the a.animate set value and put that in there. And I need a lag ratio on this. So lag ratio, I'll try 0.1. and run time of about 8. So now I'm going to have it go over 8 seconds and see if I didn't get a typo there. Okay, so it takes my triangle net, rotates it down so I can see it, and now it should start rotating, and we should see the triangles fold up into the nice tetrahedron and the full 360 degree rotation. I should be able to wait for a second, self.wait, and then basically I can kind of just have a little bit of fun. I can have self.play, a.animate. I can have it go back to flat, set value 0, runtime. It takes 4 seconds, and then I can have it just maybe essentially dance between those. So instead of that, I'll have it fold back up with this angle, I think, and then back to 0. And then I should actually be able to take this code up here and one last time maybe rotate it back to 0 degrees. So if we're any lucky at all, we should see the triangle net fade in. We rotate. We let the 360 degree rotation happen while we're folding up the side so that they come perfectly to the correct dihedral angle. And then we unravel. And we can ravel it up again and just keep going as much as we want to unravel and ravel. And then we can finish by sort of rotating our degrees back so that phi is set and we're looking at our triangle. So we've done what I think is a pretty nice job of doing this in Manim. I hope you learned a little something. I wanted to show you that basically once you have this code, you should be able to just copy and paste the code that we just did for the tetrahedron. I'm going to paste it, And then I'm going to build this into a cube animation as well. So I'm going to fold the cube. So what do I need to do? I want to do something fairly similar. I'm not going to mess with my frame. Because I'm going to need 6 squares, I'm going to need 6 colors. So I'll add gray and orange. And then instead of triangles and a triangle, I'm going to go back to the top. I'm going to take my triangle code, copy it, and paste it, and I'm going to create a square. And again, there's a square built in, but I want to do it sort of the way I want to do it. I'm going to center the square around the origin so that my rotations are easy. And that means that the 4 coordinates I'm going to use are -1, -1, 0, 1, -1, 0. The third coordinate should be 1, 1, 0, and the fourth coordinate should be -1, 1, 0. I'm still filling with the color that I pass it, opacity. I no longer need to shift it, and then this will be my square. Again, this is a square with side length 2 and centered at the origin. So now when I go back down to my code, instead of the triangles, I'm going to call it the squares. I'm going to invoke a square here. Feed the colors that I have there, but only, now I need to change it to 6 because I'm going to need 6 squares for my cube. I'm not going to mess with my value tracker. And now for all of the 6 squares, except for the 0th square, which is going to stay fixed, I'll copy the squares and I'll just change all of this. Now there's a couple things I need to change. I need to change that and that. And then now for squares, I'm no longer rotating around an equilateral triangle. I'm rotating around a square. So I'm going to want to rotate by multiples of 2 pi over 4 for my different squares. Then I'll fade in the squares. I'll still do my rotation. I have to mess with the updater, so I won't have that go. I won't have that go. And I won't have this go for a second. And then I won't do any of these for a second either. So for a second, we comment all those out and we take a look and see. Now it'll give me 2 options, and this time I want to fold the cube. And notice it drew the 4 squares and then it rotates them. Now I did have it draw 6 squares, and here it's only drawn 5, 4 around the outside. That's because one of them has been doubled up, and that's the very last one. So what I need to do in here with my code is I need to do something special for my last square. So if I is not 5, then I'll do this. But for my last square, which is else, so for my last square, I want to copy and paste all of these again. But this time, what I want to do is I want to rotate my 5th square. I want to put it right here and then shift it out a little further so that it sits on the edge of that square there. So how do I do that? Well, I still do all the same thing. This time I'm going to rotate it 5 pi over 4, or 2 pi times 5 over 4. Good. And then I need to do one more shift. So what's the shift that I'm going to do? I'm going to take the square that I have, the ith square. I want to take its 0th vertices, but now instead of sending it to the 0th square, I want to send it to the 2nd square because that's the one that it'll rotate on top of. And then I think it's going to be the 3rd vertex. And so if I go check this out and see what it did, yes, very nice. So notice the orange square, which is the 5th square, it ended up attached to the 2nd square. And the 2nd square had vertices 0, 1, 2, 3. So I sort of attached along those 2 vertices with this shift here. So that's what I was looking for. Now that I've drawn the 6 squares around in the net, now I just can do sort of the same thing that I did before. I can grab this code and replace my updater. I can grab the code for the other outer 5 squares and change my updater code there. Okay, and now again, I don't want to call these the same thing just in case there's some confusion. So I will change all of these to temp squares. Doesn't really matter, but it's going to make things a little easier for me to keep track of. Just make sure all of them change. A lot of copy and pasting, but there we go, we're done. And then now I want the object to become temp squares and just I'll call it square updater. So now down here, I no longer have the tries, I have the squares, and I need to add the square updater. This should be fairly similar. I'm still just animating. Oh, right. I no longer need to animate to this angle. I now need to do pi over 2. And I guess probably minus pi over 2 again. I'll wait again. I'll go back to 0. I'll go back to negative pi over 2. And I will go back to 0 and then set the angles. So pretty much I just copy and pasted the code from before. I'm going to run it and see if I got lucky enough for this to actually fold the cube up now that I've changed everything. So again, we rotate our phi angle so that we can look at it flat. And now as we rotate the net 360 degrees, we see that all of the sides of the squares fold up. Now there is this problem here that this top square right here, the orange one, it also rotated and did not come across the top like I wanted. And I have an easy fix for that. My easy fix there is to go back in. That's where I was messing with that square right there. If I make that square rotate twice as fast, then it should end up rotating 180 degrees. Let's see if I can make it do that. Once again, we fold the cube up and we watch really quickly. We rotate down. And now as the 360 degree rotation happens, we should watch all of the sides rotate up, and notice the top orange triangle ends up rotating basically 180 degrees, and that's why it, instead of 90 degrees, and that's why it ends up folding up all the way on top. And so I think we've actually modified our code pretty reasonably to fold up the net of a cube, just like we did to fold up the net of the tetrahedron. So I'll put both of these finished animations, I'll have them follow up right after here. I might make some changes where I don't have them make all 6 colors. I might make them uniform. Maybe I'll speed up some things or something like that. Tweak some of the code a little bit. I will post the code online, and I'll actually include posts of folding up a dodecahedral net twice, but I'm not going to talk about those. If you're interested, you can check the code. The code is a little complicated, and I have to brute force things that I think I could probably figure out a way to do a little bit more systematically if I had more time. But for those of you interested in folding up a dodecahedral net, I've got 2 different options, and I've got the code posted online. I hope you were able to learn a little something from this about Manim, about updaters, and how to use them to do this cool folding up of a polyhedral net. So stay tuned. You'll get to see the finished versions of these animations. And thanks again to the Talking Mass in Public organizers for putting on this sort of community collaboration event to show how we're doing some animations. And if you're interested in this, go ahead and check out some of the other ones. You can find the playlist on the website and see other people who've done this.